Now you may retrieve those textbooks 2A through your Google Classroom. And today we start from Unit 14. Did you all see that?
Yes.
Yeah, thank you. So it is acid and alkalis. Now today we talk about acid and alkalis. Of course, in Form 2, you have heard of this topic before. Okay, you have heard that this topic before. How much do you know about acid and alkalis? I just want to hear some of you just say aloud, or you just type it in chat box. How much do you know about acid and alkaline?
This is about the pH value.
pH. What else? I just heard of the word pH. Neutralization. What else? Good. pH. Neutralization. What else that you know about acid and alkalis? Universal indicator. Corrosive, irritant. Yeah. Corrosive or irritant. I see the word universal indicator. Corrosive, irritant, and I see one term. What you got HNOH. So what does that tell you? HNOH. You mean this? So what makes those hydrogen ion, hydroxide ion in the chemical? And you do know?
I don't know.
You just heard something about this, right?
Yes.
Now it doesn't matter. So today our today's lesson will focus on these. Yes, that's right. It is just Form 2 stuff, but you may heard I just said something like acid contains hydrogen ion and bases contains hydroxide ion. Now this one refers to acid. This one we talk about base, right? So what is mean by base?
I think something like alkali.
Alkali, very similar to the alkali, right? But is it exactly the same, or there is a difference? Excuse me. Now actually, these two terms may have some slight differences, and you will know it soon. So a very interesting finding about acid and bases that we just say acid contains hydrogen ion and bases contains hydroxide ion. Can we say that acid does not contain hydroxide ion and bases does not contain hydrogen ions? So what is mean by that? Do they have hydrogen ion in alkalis? And also, do we have hydroxide ion in acids? So it comes to our concern to this topic. So yes, fair enough. So you may have this, and indeed we have got these terms all taught in Form 2, but it is somewhat a very new topic to some of you because it is now Form 4. So here comes some more chemistry behind. Okay, so today we will talk about acids and alkalis respectively. Now, you take a look at the book. This page, I would like to refer to my copy of the book as well. It's page 2. Page 2. So you may find the acids and alkalis, they are quite commonly found besides 2. Okay, especially before Chinese New Year, you may heard of these household chemicals. Well, can you see that? For example, vinegar, toilet bowl cleanser. Some of you may think that, Mr. Chin, why do you say that you use vinegar for cleaning? Yes, that's right. Okay, vinegar can be used to clean something. Now, for example, if you have some blockage of the drainage pipe inside kitchen or the toilet, right? For example, the washing basin, the hand for the basin for washing hands. So there may be some blockage. Usually, we need to clear the blockage by two ways. One, by mechanical method. Two is by chemical method. Okay, do you know what's mean by mechanical method? For example, you use the pump. Okay, you use the pump and you can put away those, you're going to flush those blocking materials down through the pipe. But for the chemical method, we will either use acid or alkaline for help. It will help dissolve the blocking materials. It will help dissolve the blocking material. So this is what we would talk about it as the use of vinegar. Okay, believe it or not, somebody say that vinegar, isn't it a type of seasoning material? Yes, that's right. But you can also use it to deal with the blockage. Of course, it is not used by alone. Do you know what chemicals should also be used together with this? Have you ever heard of that? No. Have you ever heard of the baking soda? Soda from chloride? No, not really. Now you mean chlorine bleach? Now, if for Ho Chi-Wen's case, remember chlorine bleach cannot be mixed with vinegar while using. Do you know why? Chlorine bleach cannot be used together with acid. What is the problem? What is the problem? What is the problem? Once they react, they will give out chlorine, while chlorine is toxic. Okay? So remember, vinegar cannot be mixed with chlorine bleach. 綠漂白水 is because they will give out chlorine gas, while this is toxic. So remember, this is something problematic. Okay? Any questions so far? Okay, if not, yes, the chlorine gas is toxic. Yeah, so besides that, we will have this toilet bowl cleanser, which contains phosphoric acid. So what is the use of phosphoric acid actually? What is the use? Now check it on the word toilet bowl. So what is the problem? Kill bacteria. Some of you say kill bacteria. What else? Now I see the word toilet bowl. Toilet bowl. Now, yes, something about toilet bowl. Solvent, sterilization, kill bacteria, solvent. Now, you may get the right approach of killing the bacteria, okay? But solvent, is quite interesting, okay? So please search on the web, toilet bowl cleanser, okay? Do it now, all of you. Please search it on the web, toilet bowl cleanser. So do you see some terms here? What is that? What do you see? Can you see here? Remove swab. Remove,
Rust.
yes, rust, lime scale, and hot water stain. So what is that? What's mean by that? So indeed, acid can also react with some chemicals. So indeed, that is the main reason, okay, of the working principle of toilet bowl cleanser is used to clean, to remove some rust, lime scale, and hot water stains. So you may have some chance of going to the toilet. Now, what I mean by that, you've got the toilet bowl. Now, have you ever seen we have got a toilet bowl having two very special solid here? First of all, is here, just just at the outlet of the flushing water, and second is about the hole. The hole here, we may get some solid. Very nasty, isn't it? Have you ever seen that? So indeed, this is the lime scale. While lime scale, it is calcium carbonate. So, but the question comes, calcium, lime scale, calcium carbonate. Why do we have calcium carbonate in seawater? Think of the chemical component found in seawater. It's not just sodium ion, chloride ion, but also some calcium ion. Okay, so we would call seawater hot water. 硬水. So we search on the web and you may find the term hot water. What is hot water? Is the Hong Kong drinking water hot water? Do you know? Search it on the web. Do you know it? Now, Hong Kong, are we using hot water as drinking water? No, no. We use soft water, okay? But for some places, just like Europe, European countries, mineral water, spring water, 礦泉水, and it is full of the chemical component calcium and magnesium. Why we call it hot water? Why you say that hot? It's because it will easily cause some precipitate. Why? Because these two chemicals, group 2, belongs to group 2 ions. While the group 2, they will easily form water insoluble chemicals. So calcium carbonate is just one of these. Of course, you may think of magnesium carbonate, calcium hydroxide, magnesium hydroxide, etc. So lime scale refers to this. So what happened between the phosphoric acid and calcium carbonate is that they would react to form something water soluble. Okay, to form something water soluble. So this is what I would like to tell you about the use of toilet cleanser. Okay, do you understand? So of course, somebody would think that even though I have got Coca-Cola, you say that carbon acid, right? But have you ever heard of using Coca-Cola to clean the cooking utensils? Somebody may say yes, right? So why? Because the soft drinks also contains phosphoric acid. Wow, Mr. Chin, isn't it corrosive? Yes, somebody say yes, right? But indeed, it is related to the concentration of the acid being touted as corrosive or not. Okay, so we will talk about it later. So this is the word. Corrosive usually refer to the concentrated acid, while this one, irritant, is referred to the acid being dilute. So this is what you need to be aware of it. Okay. Now, of course, you may have some other commonly found acid in daily life, and it is quite natural. For example, yogurt. What you may find is lactic acid, 乳酸. So of course, you may heard of this term while you talk about running, right? You may find that it quite fatigue, tiring because of lactic acid. But once I talk about it in digestive system, that lactic acid is so good to you, okay? And how about tomatoes, oxalic acid, and orange and lemon with citric acid. So these three, we collectively call it as an organic acid. Organic acid. 有機酸 organic. Simply because it is commonly found in living organisms. So we will call that organic acid. Okay, is that clear? Any questions? Also, we come to the characteristics of dilute acid. So indeed, in the lab, you may have got the commonly found acid, just like HCl, H2SO4, and HNO3. Those three, they are commonly, we will call it as a bench acid because it is quite commonly used. 鹽酸、硫酸、硝酸. So we call that mineral acid because once they are just derived from the minerals. In other words, you may use it to produce some salts. Okay. In other words, you may also use it for the raw materials of making salts. For example, HCl. From HCl, we've got chloride ion, so I can make it as sodium chloride. Okay, so they are very interesting. Derived from, which means it is the original source, right? Its original source is from mineral. So in other words, I can have sodium chloride and I can produce it as hydrochloric acid. Now, for example, I put it into a concentrated acid. I do electrolysis of concentrated nitric acid, and we get H2, Cl2, and NaOH. That is what you know in form 3. While we merge the two and react, they will form HCl. And I dissolve it in water, and we will form HClAQ. So this is what we call it as hydrochloric acid. Do you understand? But if you have got HCl, I can do it in reverse. I can produce NaCl. How? It's by adding some salt, just like sodium carbonate, or sodium hydrogen carbonate. One of them we call it as a soda powder, right? Once I react with HCl, they would produce NaCl. So can you get my point? So very interesting. For the use of that mineral acid, of course, it comes from mineral salts. But I use it and I add it with other chemical, and they will turn to the salt again. Do you understand? So, what are the common properties of acid? Including the following. First of all, they are good conductor of electricity. They react with reactive metal. What is that? From potassium, sodium, blah, 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 up to lead, okay? Copper, no. Just to remember. But of course, handle this with care. If you use this to react with acid, they will cause explosion. They will cause explosion. Okay? How about react with bases? What is mean by base? Base, if it is a material in which it reacts with acid, they will form salts and water as the only product. So we will call that a base, 鹽基. So somebody will, is this what I forgot who? You just say base is just one of the case containing hydroxide ion, right? But it makes a difference between base and alkaline. Alkaline is a water-soluble base. Okay? Alkaline is a water-soluble base, while the base is not necessary to be water-soluble. Okay? For example, if you talk about copper 2 oxide, copper 2 oxide cannot dissolve in water. Right, so but once we react with acid, they will form salt and water as the only product. So we call copper 2 oxide a base, but not an alkaline. Okay, and also they will react with metal carbonate and hydrogen carbonate. So this is what you know about this. So we today our focusing point is to take a look on the activity 14.1. Sorry to say that we do not have chance of doing experiments, but let's watch the video. This one, okay? Just see if you can watch the video. If not, I will directly give you a link instead. Can you see that?
I can't see.
Oh, I can't.
Okay. Can you see that?
Yes.
Yes.
With sound?
No
No,
sound.
no
No
sound.
sound. Sorry. I do it again.
In this experiment, you are going to investigate the properties of dilute hydrochloric acid. Pour 4 cubic centimetres of dilute hydrochloric acid into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein into each test tube separately. Record your observations. Litmus solution in dilute hydrochloric acid appears as pink. Methyl orange in dilute hydrochloric acid appears as red. Phenolphthalein in dilute hydrochloric acid appears as colourless.
Okay, first of all, you may see these 3 chemicals. Please put it down. Please put it down. What are the 3 chemicals? Do you still remember the 3 chemicals? What are the names of 3 chemicals? Just to remember. Methyl orange, limits solution, and as well as what? Just one. Just one. How about the others? The third one. Now this term you have to memorize this well. P, yes. Phenolphthalein. So what is that? What are we collectively called? We call that acid alkaline indicator. So it is used to its purpose is quite similar to pH paper, to universal paper. Okay, it is used to roughly tell you the solution being acidic or alkaline. Okay, while you search on the web, okay, on these 3 chemicals, you may find it will have different working range. Okay, so first of all, to start with, please mark it down the color of the methyl orange, litmus solution, and phenolphthalein while you talk about it as in acid. Methyl orange is red.
Clean a piece of magnesium ribbon by using a sandpaper.
Litmus solution is appear in red, and phenolphthalein it is colorless. Okay, it's very special. Now, it's not necessary to be red in the indicator which tells it is acidic. Very, very strange. Okay, for phenolphthalein, we talk about pink or red being alkaline. But for colorless, it is acidic. Very, very strange. Okay, very strange example. I would like to draw attention here on this. Very strange. Phenolphthalein. Okay, is that clear? Now, I would like to show you another video. Now, a further video on reactions.
Clean a piece of magnesium ribbon by using a sandpaper. Put the cleaned magnesium ribbon into a test tube containing 4 cubic centimetres of dilute hydrochloric acid. Trap any gas given off by putting an inverted stopper over the mouth of the tube. Use a burning splint to test the gas given off. A pop sound can be heard, which indicates that the gas given off is hydrogen. Put 1 spatula measure of sodium carbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Put 1 spatula measure of sodium hydrogen carbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Add a small amount of magnesium hydroxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Magnesium hydroxide dissolves in dilute hydrochloric acid, forming a colorless solution. Add a small amount of copper 2 oxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Copper 2 oxide dissolves in dilute hydrochloric acid, forming a blue solution. Place 30 cubic centimeters of dilute hydrochloric acid in a beaker. Set up the circuit. The light bulb glows, which means dilute hydrochloric acid can conduct electricity.
All right, so I'm sure you have seen the video right about the reaction.
If you want
Now we come to this one again. Can you see that? It's the book. I just share the book here. Yes, that's right. Now this one again. Have you ever seen it? So we collectively got quite a lot of information. Let's have a summary of what we have. First of all, the action on limits, action on acid, alkali, indicator. Action of acid on it. So you may have got certain chemicals, limits is red. What else? Methyl orange. It is red. Phenolphthalein. It is colorless. Number 2. Electrical conductivity. So you know that it conducts electricity well. So just circle for me the most important words which accounts for the electrical conductivity of acid. What words is very important? What is that? 2 words. Yes, mobile ion. Okay, mobile ion. So all of you, please mark it down. Mobile ion. Now this is the very important point. Mobile ion. Okay. So the third type of reaction, your third point that you need to know is about the reactivity with the metal is quite reactive. Now, this is the key point. A metal about hydrogen in the reactive series. So, as said before, it contains what? I said sodium, potassium, very explosive. So, what's next? It should be what? Calcium. Okay, Na, very explosive, and then calcium up to lead. So, they will form a salt and hydrogen. Salt, what does it mean by that? Salt, it is a very special term, but you may get it as a cation plus anion, positive ion and negative ion. Which is positive? It comes from the metal. And what is negative here? It comes from the acid. Okay? So I would like to show you this equation and you can get what I mean. Now, take a look on these 2 equations. One of them I use dilute hydrochloric acid. The other one I use it as a dilute sulfuric acid. So, what are the common points? Hydrochloric acid contains chloride ion, so the salt form will have chloride. The sulfuric acid will have got sulfate here. Of course, the salt will have got sulfate. How about the metal? For magnesium metal, it will form Mg here. Iron, it will form the salt to form iron 2 sulfate. What is left behind? Yes, that's right. So this is the hydrogen ion case. Hydrogen ion, they will form hydrogen gas, and hydrogen ion here, it is also form hydrogen gas. Now remember, these 2 hydrogen is different. Now this is the hydrogen gas. It is a hydrogen molecule. But for this one, it is just hydrogen ion here. Now remember, it's different. Now, while this one hydrogen ion is in 2:1 ratio. So I write it down H2SO4. But it is not telling you that it is hydrogen gas inside H2SO4. It's hydrogen ions with a mole ratio 2:1. Do you understand? Huh? Remember, these 2 very similar, but do not get confused. Can you get my point? So it's a matter of the speed of the reaction. Okay, magnesium loses electrons more readily, so of course the evolution of a bubbles is quicker. Okay, when you compare with iron, it's easy, right? How about base? Base, what makes as a base actually? Mr. Chin just tell substances in which it react with acid to form salt and water. So a base. Now, that is the definition. I would like to draw attention. Could you please highlight it? A base is substance if we react with acid and to form the salt and water only. And the reaction is salt and water with the product. And this, we will call that as neutralization. 中和作用. So, in Form 2, what you have learned is just half of them. Because we just talked about alkali. React with acid to form salt and water. But indeed, we have got a big world of having water insoluble base, which will also react with acid to form salt and water, and we still call it neutralization. So you will be given this one as example. Copper 2 oxide is insoluble in water. So just to remember the color of copper 2 oxide, It is black. While it doesn't react with, it does not dissolve in water, but it dissolves in acid. Indeed, it's not this dissolution in acid. It's a reaction. It reacts with the dilute sulfuric acid to form copper 2 sulfate water. Now, because we have got copper 2 ion in aqueous solution, it appears blue. So we call it a blue solution is being found. So you may find this one as example. Now, just like the previous page, okay, of the book. Now, you may see the cup zinc of hydroxide is water insoluble water. It reacts with acid to form zinc chloride and water. Now, could you please underline there? Now, in order to memorize this, okay? So copper and copper. Can you see that? Zinc to form zinc as a salt, and sulfate, chloride. Okay, you get my point. So what is left behind? O and H. O hydroxide and hydrogen ion. What is the fate? What will we form? Yes, that's right. It's water. It's water. Can you see that? So it seems like changing in the position of the two to get what you want. Okay, it seems like a change of part of the chemical to the other. I exchange the information, and you can get the salt and water. Now, believe it or not, I changed to a different case about the metal carbonates and metal hydrogen carbonates. They both react with acid, but this time it will cause salt and water and also carbon dioxide. So it is not neutralization. Though this arrow, it seems like very similar, right? You have got salt and water. Very similar, but it's not neutralization because HCO2 has also been formed. So you take a look on that. Now, for example, if you have got calcium carbonate and sodium hydrogen carbonate, they will react. Can you see that? They will also react with the acid. Now, this time is dilute HCl, dilute sulfuric acid. So use the similar way to tell me how the salt is formed. Okay, calcium, sodium. What's next? Chloride, sulfate, calcium, sodium, right? Can you see that? So what is left behind? Carbonate, hydrogen ion, hydrogen carbonate, hydrogen ion. So what will we form? It is CO2 and H2O. It seems like having a merging of calcium and chloride ion to form calcium chloride, sodium ion and sulfate ion to form sodium sulfate. And leaving behind is the calcium, carbonate ion and hydrogen ion, and they will collectively change it to carbon dioxide and water. Can you see that? Hydrogen carbonate, hydrogen ion to form carbon dioxide and water. Now, that type of thinking is very important because it will help you write down the ionic equations later on. Understand? Now we come to this diagram, right? In case I have got carbon dioxide, we will be released as a colorless gas bubbles. We call it effervescence water. And the presence of CO2 can be tested by bubbling the gas through lime water. So the lime water turns milky first of all, but if I got excess carbon dioxide, it will turn clear again. So this is the two equations. Do you still remember that? If you have got little CO2 react with lime water, it is calcium hydroxide. They will form calcium carbonate and water. So because calcium carbonate is water insoluble, it forms a white PPT, so you will see it as a milky solution. But later on, that milky solution becomes clear again because it forms a water-soluble calcium hydrogen carbonate. Okay, so this is what you know about this. And in the video, we just show you the experimental setup. Could you please draw the experimental setup in the book as well? What is the experimental setup? Give me the marker. The experimental setup for this reaction. So you may find this. Do you still remember that? Now this is the setup. They show it in the video. Do you still remember that? So a very typical setup, which tells you the reaction between metal carbonate or metal hydrogen carbonate react with acid to form lime, and the gas form is now passed through the bubble is by bubbling into lime water. So that's why here comes a stopper here. Stopper here to confine the gas flow. The carbon dioxide, once it is formed, it will pass through here, here, and here, bubble up, and we will turn lime water milky. Okay, so it will meet calcium hydroxide, and the reaction is set as written in the equation. Carbon dioxide react with calcium calcium hydroxide to form calcium carbonate and water. Is that clear? Okay. Other way. Now we come to this. Now, on the top left-hand corner of the book, page 7, that you may see it on here, the calcium carbonate then also react with dilute sulfuric acid. But once they form calcium sulfate, what will happen? The reaction quickly stops. It's because the calcium sulfate form is insoluble in water. It will form a coating on the surface of the calcium carbonate that will stopping any further reaction. Have you ever heard of this phenomenon? We call that coating effect. So what does it mean by that? Once I put a piece of calcium carbonate and with H2SO4, so what will happen? Once the reaction will go, as calcium carbonate react with H2SO4 to form what? Just like last time, what you merging the two, and you will see the calcium and sulfate. And this carbonate with hydrogen ion will be formed CO2 and H2O. But indeed, I would like to draw attention on this. Don't be so casually write as AQ. It's solid this time. Why? Calcium sulfate, it is water insoluble. Okay, I draw attention on this. Calcium sulfate is water insoluble. So what is the consequence? Is that once they will react with acid, it forms a layer of water insoluble salt, calcium sulfate, and they will cover on the surface of the calcium carbonate, while these two chemicals can no longer react. Okay, so we call this coating effect. Coating effect. Questions? Any questions? Now, if not, now we have got 9:26 now. So could you please take a look on the class practice 14.1 as a overall recap? 14.1. The lesson will end at 9:35, is it?
Yes, yes.
Okay, so spend some time on doing this. First one, iron plus, you're going to write down the products for each equation and write down chemical equation. First of all, iron, hydrochloric acid. And then lime water with hydrochloric acid, magnesium carbonate, hydrochloric acid. Lime water, it is calcium hydroxide solution. So we've got calcium and called hydrochloric. I underline part of that to help you get to know what other product. Iron 2 chloride. The second one is calcium chloride. How about the third one?
Magnesium chloride.
Yes, magnesium chloride. So what is left behind? Hydroxide, carbonate, hydro. So what is the product? The first one. It's just what hydro, right? Of course, we talk about it as hydrogen. The second one, hydroxide and hydro. So what will we form? It's water. How about carbonate and hydro? Do you see the pattern? Do you find the pattern? Okay, so what should we do next is to write down the equations for the reaction involved. I put it on here. Iron and HCl to form iron 2 chloride and hydrogen. Now, if you take a look on that in blue, iron chloride and iron 2 chloride, hydrogen ion, hydrogen gas. It's very similar to word equation. Huh? So you do the same. Can you do the same for the other? Lime water. HCl, calcium chloride, water. Okay, calcium chloride, and we have got hydroxide, hydrogen, water. But this is not the end. You need to do something. You need to do something for the first two equations. Something has been missed out. What is that? Balance equation. You're going to balance the equation. How about the third one? Magnesium carbonate, HCl, from magnesium chloride, CO2, and H2O. Okay, magnesium chloride, carbonate, hydrogen ion, CO2, and H2O. And finally, remember to what? Balance the equations. Is that clear? Now, for the question 2, I leave you guys to do it at home, and I will check question 2 right away. Okay, so in the next lesson. Now, let's have a recap of what we have known about acid. First of all, the source. Where can you find the acid in our daily life? Mainly three ways. One, in the school lab. In terms of what? 喺實驗室入邊揾到啲咩啊？喺邊啲酸啊？揾到？其實喺實驗室入邊大部分嘅酸都揾到嘅，唔係淨係揾到呢三隻啊。Okay, it is HCl, H2SO4, and HNO3. So that these three are more commonly found. But of course, we can find a lot. And indeed, at home, you may have got the two ways of getting the acid. One, it is from the natural materials, just like yogurt, tomatoes, orange, lemons, vegetables, etc. But you have got something man-made, for example, which can be drunk, which include vinegar, soft drink, but also which you cannot drink it. For example, portable cleanser, household chemicals, and you may find that. And lastly, you talk about the property of acid. Could you please remember this? The property of acid, including they are good conductor of electricity, the reaction with metal, the reaction with base or alkali, and the reaction with metal carbonates and hydrogen carbonates. Okay. Is that clear? Any questions so far? Now, before you leave, could you please type your number to tell me your level of understanding? Now, easier stuff, isn't it, right? Because some of them you have heard it in Form 2. Yes, quite nice. Yep. Okay, any more questions? Now, if not, you may now leave. Okay, see you guys. Bye-bye.
Bye bye. Bye bye.
Bye bye.
Bye bye. Bye bye.
Bye.